Hello and welcome. In this video, we'll be learning about geometric sequences and series. Right, so how do we write geometric sequences in algebraic way? First term again will indicate by A, and common ratio we are going to use letter R to indicate it. So first term would be A, second term would be multiplied by R. A times R is AR, and the next term would be multiplied by r again. So multiplying by r each time will give us these variables: first, second, third, fourth, and so on. Notice that the position here is the first, second, third, and fourth. So the fourth number has only r to the power of 3. So can you guess what's the nth term formula going to be? It's going to be AR to the power of n minus 1. So just remember this and it will help you solve the problems in the next few slides. So in the first example, we've been asked to find the 10th term of this sequence. The sequence is geometric because numbers are multiplying by 2. Once again, if you've forgotten how to calculate the ratio, you take the second term and you divide by the first. 6 divided by 3 is 2, or 24 divided by the previous term is 2 as well. So we have a common ratio of 2 and the first term 3. We were going to calculate the 10th term. So AR to the power of 10 minus 1. AR to the power of 9 is 3 times 2 to the power of 9, which is 1536. Next question is asking us to calculate the 10th term in this geometric sequence. The common ratio is negative half. If you divide minus 5 by 10, you get negative half. Or if you divide any other term with its previous term, you get negative half. So we use the same formula again. Because we're looking for the 10th term, the n value will be 10. 10 minus 1 is 9. So you put this into your formula in your calculator and you get such fraction. Let's look at another example. So here we've been told that the second term of a positive geometric sequence is 4 and the fourth term is 8. Okay, make note of the fact that it's a positive geometric sequence. That means the ratio has to be positive. So second term, the second term has formula of AR. So we can write A multiplied by R is 4. Notice A is unknown still. We know that the fourth term, that is AR to the power of 3, is 8. So how can we find value of R and value of A? Can we add these two formulas with each other? Not quite, because adding them will give us yet another more complicated formula. In general, when you work with geometric sequences and series, it's best if you come up across these equations that we've made so far, it's best to divide one by the other. If you divide the second one by the first one, you get a simpler answer. AR cubed divided by AR will leave us with R squared. Now, if we divide the second by the first, that means we were dividing 8 by 4, which is a 2. So R squared is 2, therefore R is root of 2. Notice root of 2 could be positive or negative, but since we've been told that this sequence is always positive, we're going to ignore the negative answer here and take R to be positive root 2. Then we need to calculate value for A. Well, we know that a times r is 4, therefore a multiplied by root 2 is 4. All you have to do is divide 4 by root 2. Well, 2 times root 2 times root 2 is another way of writing 4. Dividing by root 2 will cancel away one of the root 2's and we're left with 2 root 2. Okay, I'm gonna wipe off my handwriting so that I can show you the next example. So far, we went through these calculations. So in the next example, we've been told that the number 3, x, and x plus 6 form the first three terms of a positive geometric sequence. We've been asked to calculate the 15th term of the sequence. So, we need to first calculate what value of r is. We know the first term is 3, but that's not quite enough to help us figure out the ratio. Another way of thinking about common ratio is dividing this next term by the previous term. So, or current term divided by the previous term. So that means that x plus 6 divided by x is one way of writing r, and another way of writing r is x divided by 3. So in our case, that's the second term divided by the first, has has to be equal to the same ratio that the third term has with the second term. So knowing this, we can ignore the fact that this equals to r and just solve it for x. So solving this equation for x, what we get is a quadratic, because we have to multiply both sides by x and 3. So solving that for value of x, we're going to have x equals to 6. Why do we not take x equals to 3 to negative 3? Because we've been told it's a positive geometric sequence, and we are ignoring the fact that x could be negative 3, because it cannot go from 3 to negative 3 and so on. So that's why we're discarding this answer here. Then we substitute the value of 6 into our equation. So we have 3, 6, and 12, and so on. So what's the common ratio now? The ratio will be 12 divided by 6 or 6 divided by 3. R will be 2 in our case. So the nth term would be 3 times 2 to the power of n minus 1. And now we can calculate the actual value of the 15th term. Substitute 15 for n into this formula and you will get 49,152. Okay, so let's look at next example. In this question, we've been asked to find the first term of the sequence that will exceed 1 million. This sequence is 3, 6, 12, and 24. It's just like the last example we looked at, but the question is different. The value of a is 3 and the ratio is 2. Okay, so the nth term has to exceed 1 million, which is 10 to the power of 6. So we write a r n to the power of minus 1, and we write this formula exceeding 1 million. So one way of writing it is like so. We need to figure out the nth term. Because n is in the exponent, we have to solve it with logarithms and exponentials. So first we divide by 3, we'll get such an expression. Then we'll take log of both sides because we want the index to come and sit at the front, in front of the log. So we'll have such an expression. Using log rules, we bring the power down, n minus 1 in brackets. Alright, so then we know that this is a constant. Log of 2 is a constant, so we can divide both sides by log of constant. Be careful. If you have log of a number where this number, let's call it x, if x is less than 1, your logarithm would be negative, so you would have to switch the inequality sign. But we know for a fact that this x here is positive and is bigger than 1, so we won't get a negative log. So dividing by log of 2 is fine in this inequality. You don't have to switch the inequality. So then we'll have n minus 1 is equals to this expression. Then we add 1 to both sides and evaluate it on our calculator. You get a decimal number. The first number that's bigger than 19.35 is actually 20. So the position of the number that would exceed to 1 million is 20th number. Okay, so happy practicing. I'll see you in the next video.